We are starting our Unit 10 packet over polygons and quadrilaterals. This is a PowerPoint that I will make available to you. I'll post it both on my website and I will post it on Edmodo as well. You can go through it if you need to. It just kind of goes over what polygons are, all the different names for polygons and things like that. But I am going to make a video that kind of goes over it as well. So y'all have, this is page number 2 in your packet, all these polygons, and then this is page number 3. And I'm going to use page number 2 to fill in things for page number 3 so that you know. So what I'm going to do is I'm going to use these letters to fill in these different vocabulary notes. So polygons are two-dimensional objects that do not cross each other. So all the polygons on this page, you have A through R. S is not a polygon because it is two-dimensional. T is a polygon. U is not a polygon. Circles are not polygons. They have to have straight lines. V is a polygon, and then W and X are not polygons. W crosses, it has lines that cross each other, which makes it not a polygon. It could be two polygons put together, so two triangles put together, but the whole shape itself is not a polygon. X is also not a polygon because they cannot be open. They have to be closed. There's a difference between convex and concave. Let's do convex first. Convex just basically means that it points out, so all the sides point out. So you see how all of our corners, they point out like an arrow. That makes it convex. So A is convex, B is convex, C is convex, D is convex, and E is convex. So A through E are all convex. F, you see how this side actually points into the polygon, and so does this one. So these two sides right here that point in make F concave. So F is concave. G, H, and I are all concave. So G through I are all convex. So G through I are convex. J, because these sides point in right here, it is concave. K is convex. L, because of this point right here, is concave. M is also concave. So L and M. N is convex, all the ends point out. O, because of this right here, is concave. P is convex. Q is convex. R is convex through R. S, of course, is not a polygon, so it can be neither. T is convex. U is, of course, also not a polygon, so it can't be either. And V is convex. So the pink parts are tell you what it is, why it makes it concave. And then all of these, since all of them point out from the center of the polygon, that's what makes these convex. So everything points out away from the center. When they point in towards the center, it makes it concave. So pink is what makes it concave. Okay. Now we need to talk about equilateral and equal angular and what makes them regular. So, equilateral means that all sides are the same. So we know that all of these sides, or I'm pretty sure that all of these sides are equal to each other. All of these sides are equal to each other. All of these sides are equal to each other. And D and E already shows you that all the sides are equal to each other. But they actually have something else. So right now it's just A, B, and C. So A through C. I believe K, all of its sides are equal to each other. N sides are equal to each other. O sides are equal to each other. V sides are equal to each other. And then of course, this one shows me that they are equal to each other as well, all those sides. And these are all equal to each other. And this one too. So all the different ones that are equal to each other. We have A through E are equilateral. I is equilateral. K is equilateral. N and O are equilateral. R is equilateral. And V is equilateral. So those are the ones where all the sides have the same length. Now we need to look at all of the angles. These don't tell you, but all the angles are equal on them. This one doesn't tell you either, but all the angles are also equal on this one. C, all the angles are equal. D, it shows you all the angles are equal. E, it shows you all the angles are equal. G shows you that all the angles are equal. H shows you that all the angles are equal. I shows you all angles are equal. N, all of the angles are equal. P, all the angles are equal. Oh, you know, P should have all the sides equal too. I left that one off. It should be it should be N through P, not O. Sorry. This should be P. All the angles are equal on R. And that's it. So, equal angular are A through E, G through I, N, P, and R. So those are all the equal angular. Now, the ones that have both equilateral and equal angular, so the ones that we have the same are called regular polygons. So A through E are regular polygons. All of these are regular polygons, meaning all the sides are equal and all of the angles are equal as well. So whenever we refer to regular polygons, we're referring to those. E is a regular polygon. G is not, because not all the sides are the same. H is not, because not all the sides are the same. I is a regular polygon. N is a regular polygon. O is not, because not all the angles are the same. P is a regular polygon. A square is always a regular polygon. equilateral and equal angular triangles are regular polygons. And those are it. So we have A through E, I, N, P, and R. So those are all regular polygons. They're polygons that have both all angles are equal and all sides are equal. Irregular polygons are any non-regular polygons. So all of the others, all of the non-yellows, let's make them green. Let me see. All of these are the regulars. Everything else that is not part of a regular polygon is an irregular polygon. So if I make them green, all of these are irregular polygons, as long as they are actually polygons. So the ones that I said that are not polygons, they are not irregular, because they are not polygons. So those are all of the irregular polygons. So F through H, J through M, O, Q, T, and V are all irregular polygons. They do not have equal sides and they do not have equal angles. Names of polygons. If you have 3 sides, you are a triangle. If you have 4 sides, yes, you want to say square or rectangle. That is not true. It is called a quadrilateral. Five sides is a pentagon. 6 sides is a hexagon. 7 sides is a heptagon. 8 sides is an octagon. 9 sides is a nonagon. 10 sides is a decagon. 12 sides is a dodecagon. And whenever it says n sides, it means that it could be any amount of sides. We call it an entagon. And we're done with the current set of notes.